Hello, everybody. Welcome to another episode of Bitcoin Developers. I am your host, Connor Okus. I'm glad you could join us today. It's been a while. It's been a minute. What have I been up to? I've been head down, kind of working on just building Bitcoin throughout this frantic bear market. Spent some time at TabConf in Atlanta. So if you was in TabConf and I got to speak to you, um, thanks for coming. The shout out to the organizers of TabConf, Stephen DeLorme and Michael Tidwell and all of the team over there put on a really good conference. I had a number of different workshops and talks and had something called a builders day where teams would organize themselves in their respective teams and have contributors from those projects work with individuals who were interested in either using the tools that these projects were creating or needed help debugging certain things. So it was awesome to see some folk in person as well. But I won't blabber on for too long today because we've got another amazing episode. Like here, we're trying to be very practical, very hands-on, give you a range of tools and diverse perspectives on how you can get involved in Bitcoin and what tools you can use to build on Bitcoin and adjacent technologies. So without further ado, I'll introduce my guest. I have Dhruv here with me today. How's it going, Dhruv?
Hey Connor, I'm doing well. Thank you for having me.
No problem, man. Thanks for joining me today. We've got a awesome stream ready for people today. But I usually start with guests that haven't been on the show. Just give people like your origin story of how you got into Bitcoin.
Yeah, sure. So I kind of like to think of it as like I got very early exposure to people who were excited about Bitcoin in 2013. But I kind of think of it like there was a libertarian wave, then there was a technologist wave. I missed both those, and the financial wave was finally caught my attention, unfortunately. But yeah, I heard of it in 2013. But these were friends who would like they were older. I had just moved to the US, and these guys would like bury gold in their backyard. They were very anti-authority libertarians, which I'm closer to that now. But back then, I thought it was like a little wild. Their ideas were a little wild. They were really into Bitcoin, and so that was the first time I heard of it. And then in 2016, living in SF, everyone was talking about Ethereum stuff, and I just was so skeptical, and I couldn't wrap my head around like, okay, so but you can just make another chain. Like I couldn't understand why the finite supply mattered only with network effects back then. That held me back, and the block wars didn't help because I was like, oh, here we go, this is the thing that's confirmation bias happened to me. And then in 2019, there was a day I remember very clearly. I was going for a run, and I thought to myself, why am I skeptical of Bitcoin? And the only answer I could come up with is I had always been skeptical in the past, so I'm skeptical, and that's a terrible place to be. So I started. I listened to a couple podcasts. I started studying it. I took courses at Berkeley. Blockchain at Berkeley is a very cool group, and they have a Bitcoin course and an Ethereum course. So I took those, but I was becoming a user of Bitcoin at that time and starting to study it and more fascinated, and kind of had the mindset of like, there's no way this works, like I cannot believe that. I cannot believe this. And so I kept digging, and yeah, I just, it had my attention very strongly. And there's this interesting thing about Bitcoin where there's so many facets to it, like computer
Mhm.
science, economics, finance, there's
Mm,
networking, there's just so much going on that you kind of have to you cannot study it linearly the way a lot of other subjects can be studied linearly. It's kind of more like an onion, like it just keeps coming undone as you study more and more. And I had to learn to Bitcoin has taught me to suspend disbelief about parts of the system that I haven't studied yet, and study one part and then go back to the other parts. And yeah, it's
what do you
just,
mean by suspend disbelief? I like that term, but I'm not quite sure I know what you mean.
yeah. So for example, let's say you're trying to study the P2P adversarial thinking parts of it, like how do you find peers, eclipse attacks, and that kind of thing. At that time, if your brain is still trying to process like the finite supply thing and the social consensus thing, then my brain at least does this thing where it 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 distracts me, right? I can't focus on the thing. I had to pick one thing and just believe the finite supply thing for a bit,
Hmm.
and then go back and like unravel that and open that box up and study that. And you cannot study it linearly. A lot of other topics you can build them linearly because the theories have been developed over time, but Bitcoin is an
I get you.
application of so many different areas rather than being a new theory that you
Hmm.
have to there's like, people talk about a rabbit hole. I feel like there's like one rabbit hole, but then there's like 7 different tunnels inside, and you have to like
Mm.
go into one and then come back and trace. And
It's like never ending, right?
yeah, and it's fascinating. Even with core
Mm.
devs, people just know so much, and I have so much respect for the group of people I am privileged to get to work with. But even amongst that group, they are experts in a part of the Bitcoin code base,
Mm.
and you start talking about the other parts, and they are just as fascinated and mystified by it as you are. And
Hmm.
so, I mean, there's obviously some people who know almost everything. um, but yeah, so it's, I think the gift Bitcoin is giving me is the gift of study. Like I get
Hmm.
to do something very interesting every day. I never get bored. And then the gift of optimism, like Bitcoin makes me feel hopeful that there is an alternate system where we can opt out. And so rather than just being hateful or resentful about everything else, if you feel down, let down, you can actually constructively contribute to the protest, and build the new world. It's just a better way to live. Even if it doesn't work out, I will have lived feeling optimistic at the end of it.
Yeah, I definitely second that. Just looking in the chat and seeing what kind of numbers we've got. We've got double figure number of people joining us, so that's good. Like I always like to hear where you guys are tuning in from. So if you feel so inclined, let us know what city, town, country, part of the world you're tuning in from. You mentioned a little bit about Bitcoin Core and development. So can you talk to you are a Bitcoin Core developer? Can you talk to a little bit about that? What that means to be a Bitcoin Core developer and how you got into core development?
Yeah. One thing I like to remind people of, like, people think Bitcoin core developer is Bitcoin core developer, but it's Bitcoin core developer. So I work on the reference implementation of the Bitcoin protocol, which is called Bitcoin Core.
Hmm.
Uh, Famously, this was the project started by Satoshi Nakamoto in 2000. I imagine he started coding in 2008 and started running in 2009. Um, yeah, so all that means is I contribute code as a contributor to the Bitcoin Core repository, and um, work with other developers there to kind of, yeah, build, test and review things. Yeah.
Hmm. Awesome. And what advice would you give to someone who wants to get involved in Bitcoin core development? Like they've kind of discovered Bitcoin, they're got strong technical skills, and they want to work towards being able to contribute to this journey of Bitcoin. What would you suggest? How do they get started?
Yeah, I hesitate ever to give advice because I'm not an expert in anything, but I will tell the story, I guess, which might answer how I did it a little bit. So, when I was studying Bitcoin, I felt I was, doing those courses at Berkeley, and I was reading Mastering Bitcoin, and there's just so much there. I remember I was walking along the water with my wife one day, and she was like, it feels like I was just obsessed with it, couldn't stop talking about it. So she was like, it feels like you could keep studying forever. But how about like doing something with it? Like, why don't you reach out to someone? And that's when I found Amiti, her article on onboarding to Bitcoin Core, and I reached out to her and I said, what I had done, and what I wanted. And she sent me like a little challenge. There's this file called example test.py in the integration tests in core, and she said, can you change the test to do this instead of this? Or she gave me a little challenge, and I was able to do some of it, but that got me compiling the code, that got me running the test, and I kind of had to come out of the books and the articles and the courses, and like I used to think I have to learn all of cryptography before I can even, it's called cryptocurrency, like I have to learn cryptography first. But you don't have to do that. You can
Hmm.
start doing something. So that's one story, and then the other story is, this actually is advice. I will this is controversial advice. I will
Okay.
go there because I feel like a lot of the advice in the ecosystem is to opposite of this. So I'm going to
Okay.
go there, and correct me if you feel otherwise. I want to hear your
Hmm.
thoughts on this too, Connor. But
Hmm.
I think far too much of the advice to people that are getting started in our ecosystem is start slow, write some tests, write some documentation, review is all the project needs. I agree those things are useful, but I think we're making two mistakes. I think we need to meet people where they are. So do what interests you. Is like it's like don't let me tell you what you should do. The only thing is do something and do what interests you,
Mm.
and then over time you'll grow to appreciate what the project needs. But in the
Hmm.
beginning, you know not so much. And I would like to see, right now I think we're in this place where everyone starting is doing a lot of small things. So
Hmm.
I see a lot of integration test changes, a lot of reviews, and this is all positive. But also, it's okay if you want to do a big project, if you want to question something big, if you want to go take a big project like Erle and study it in and out and help Gleb push it forward. Like,
Hmm.
if you want to come help me with, BIP324, like, it's don't hold back. You don't
Hmm.
have to start small. It's just you are less likely to receive that dopamine hit that you get
Hmm.
from small tasks. But not everybody's brain is wired in a way that they absolutely need that small dopamine hit.
Hmm.
So yeah, I would say,
Yeah.
like, make sure to do what you want to do, because that's the only way you can sustain something, is you're actually truly interested.
Yeah. I think I definitely agree with that. It's actually one of the principles I try and actually live by. Is like just you need something that's gonna help you remain curious and interested. And we do have an obligation to help galvanize people's energy towards wanting to work on Bitcoin. Period. Although I don't want to speak for like Cora and its specific needs. Like, yeah, there's a need to review. There's a need to do cleanup and make things more modular and things of that nature. But maybe the entry point for someone might be that thing that they're super enthusiastic about, and through their journey of learning a bit more about the project, it becomes obvious to them that there are maybe less glamorous tasks that they can also um, help with. But then there's also the opposite, where some people genuinely might need to start quite slow,
Sure, yeah.
reviewing smaller things and testing and fixing bugs and things of that nature. So it's definitely very should be very tailored to the individual. So I definitely respect that. And then yeah, one last thing before we dive into to let the people know about what we're going to be working on today. Just to touch on it a little bit from the developer's perspective, we are obviously in a bear market, and like this stream is not to talk about price or anything like that. But how does it feel to work, in a space that has up to this point now has a lot of society's eyes on it, much of it in a negative light. Um, Things are on a bit of a downer at the minute. Um, Bitcoin gets cloaked in with the wider crypto ecosystem and much of its shenanigans. How do you you know stay clear of that in terms of like trying to just focus in on Bitcoin and making Bitcoin stronger and trying to stay away from a lot of that noise?
Yeah. So I think, and what's happened is really sad, but it is consistent with human nature. uh, has happened before, will happen again. And it's just really important to know why we do what we do. You have limited time on the planet, and why you're doing what you're doing is something only you can answer for yourself. For me, the reason I work on Bitcoin is this. I have kids, and what I've learned is, so in 2020 and 2021, everybody felt like they should buy a new car. Everybody felt like they should buy another house because they took the rates to zero and they gave out checks. And now they were like, oh, you guys feel too rich. We want you to feel poorer. It's not like you got richer. It's not like you're getting poorer. But they wanted you to feel richer so you would stay home when they asked you to stay home. And I'm not like, just to be clear, like, I was scared of the pandemic and I wanted to stay home, but that was something I felt. It was not something they made me feel, but they made us feel richer. And now they want us to feel poorer, so we go back to work because they need to increase productivity. And there's all this other macro stuff going on with supply chains and geopolitical relations. But now they want us to feel poorer so they can make us feel poorer. And what bothers me about this is the US dollar's reserve status basically means that the Federal Reserve has right access to the feelings of 8 billion people. That is messed up. Like, they have right access to not just your thoughts, but your feelings, unless you're very, very mature about it, which I haven't been. And so I want my kids to live in a world where they can truly figure out what they're feeling, rather than someone having this access to edit their feelings. And that's why I work on Bitcoin. And so, yeah, price is a very exciting aspect of Bitcoin. Like, yeah, like I'd be lying if I told you I don't refresh the Bitcoin price every now and then. But it remains the least interesting thing about it. So exciting and interesting can be conflated easily, but it's not. Price is not interesting. It's very boring, actually. It's a number that goes up and down. But what's exciting is that when you want to send Bitcoin to someone, nobody can stop you. That's exciting. Like, that's power. Like, the first time I remember I took self-custody first time, I felt so powerful. It's just addictive. I love it. So
Superman Dhruv.
yeah, it's just important to know why we do what we do, and then hold that truly. You write it down, go back to it if you have to. But yeah, there's a bear market. Yes, there's macro stuff going on. Yes, SPF seems to have, at least from the looks of it, screwed over a lot of people. Maybe there's more to it. I don't know, but that stuff it happens every 3, 4, 5 years. As I've grown older, I've gotten bored of it. It's just boring.
Yeah, makes sense, man. Makes a lot of sense. But we're here to build. We're here to work, and yeah, sometimes bear markets are the best time for that. So let's get into it. So let me I'm just going to share one of my windows very quickly, just to remind people of a few things. Yeah, so we are, we live stream here on Twitch, and we're on Twitter as well. Maybe one day on YouTube, but we do have a YouTube channel, and where we upload all of the videos after. So if you haven't subscribed already, please do. Please share the channel around. We're at, what are we now? 489 subscribers, man. Like, by the end of tonight, that's got to be at 500 subscribers, and I'd like that nice round number. And maybe you guys can give me some early kind of Christmas gifts in the form of YouTube subscribers as well. That would be awesome. And Dhruv, I guess like one of the places people can follow your work and see what's going on with you is Twitter. Yeah, your handle's at Dhruv.
Yep.
Is that a good place for people to follow you? Okay, cool. So let's talk about what we're going to actually, the nuts and bolts of what we're going to do in today's live stream. As many people know, like, Bitcoin doesn't have the strongest privacy across different layers of the Bitcoin stack itself. We're going to be specifically talking about its privacy at the peer-to-peer layer. So yeah, do you want to talk about BIP324, how you got into working on it, and then what we're going to do in today's live stream to help people learn about it and get more familiar with it?
Yeah, absolutely. So BIP324 has a pretty rich history. So first, let's talk about how the protocol works today, right? So one of the key things is Bitcoin is public and permissionless. So there is no private data on the blocks, because the blocks are fundamentally public. There's no private data in the mempools. It's fundamentally public. However, there is private data in the metadata that can be collected on the network. So a lot of these chain analysis companies, they make a lot of connections, and they monitor how the transactions are being relayed, for example, and they can, kind of pinpoint where the transaction originated, where the miners are located, so on and so forth. And the metadata is really, really important. Like, who is telling, which node is telling which other node what at what time. And that basically, if you think of the network, is just the data that ends up on the blocks and on the mempool, but it's also a series of from IP address and port to IP address and port, and what was said and the time. And so the time and the from and to aspects of it can be very, very leaky for privacy. So that's one thing. And today the protocol is in clear text. So you don't even have to make connections with everybody. You could just be the ISP doing deep packet inspection. And what deep packet inspection means is, typically a TCP/IP router is only supposed to look at the destination for a packet and then just route it. But if you're looking at the contents of what's in the packet, that's a layer violation. Like, this is, for example, how China firewalls a lot of stuff, right? They look at the packets. So deep packet inspection can immediately reveal that TCP/IP connection is a Bitcoin connection, because we have things like the first 4 bytes of every P2P message are something called network magic, which is always the same. So if you literally look at the first 4 bytes and it's those 4 bytes, you could just drop the packets as the ISP, and that connection would be censored. So privacy is sort of a prerequisite for censorship resistance. You can't have censorship resistance without privacy. And so this is why BIP324 is about adding privacy and therefore increasing the cost of censorship resistance. We want the attacker to have to do more than just deep packet inspection if they are going to drop all Bitcoin packets, for example. And we want them to occur at collateral cost. There should be some other damage. Right now, they can. So if you think of like an ISP and you think of all the traffic on the internet, they can selectively point out what is Bitcoin traffic. Like, with 100% certainty, there's no collateral damage. There's no, oh, actually, we might be dropping packets for other things. And so there's no probability. It's 100%. We want to increase that collateral cost.
Have we had any instances that we know of censorship with at that layer, and like the implications it's had for everyday users? Or so far it's kind of, we know it exists, but it's not been perhaps exploited to the degree it could?
So 2 things there. One is anything that can be done will be done. It's a question of time and importance. So I don't really like, probability is not as important to me as possibility. And the second thing I want to say is, today you can do it covertly, right? So if you are running a Bitcoin node and I'm running a Bitcoin node, and I want to connect to your node and I make a connection, then ISP can selectively, like we talked about, they can isolate the Bitcoin traffic and drop it. you don't even know that your ISP has attacked you.
Okay.
Right?
Okay.
You wouldn't even know that I was trying to make a connection to you. The packet was just dropped. And so today that can be done covertly. And one of the goals of the BIP is that we make it detectable, because so we raise the bar from passive attacks to active attacks, which I can explain the difference between those in a second. But we raise the bar from passive attacks to active attacks, and then also the attacker has to incur the cost of revealing themselves as an attacker, which today is not the case. They can just covertly do it. And Ben the Carmen just said that Starbucks wouldn't let him download Bitcoin Core, right? So
Yep.
that's interesting.
That's a concrete example there. Okay.
Yeah.
Why is Starbucks not allowing you to? Starbucks need to fix up. But yeah. Okay. And so you've explained a little bit about where we're currently at. How does what you've done in the like version 2 of this newly designed protocol help kind of mitigate against some of the things you just described?
Yeah. So I'm gonna throw in a link here. I guess I will give it to you, and then you can send it to folks. This is the BIP itself, and I'll be looking, or you can bring it up, and we can go to the goals.
BIP, this is the pull request. Okay, the BIP's here. Yeah, cool.
Can you click on the rendered version? The
This
link
one.
in the
Yeah.
And then go to goals.
Okay. Yeah.
Okay, so these are our goals for the project. So we've so today the protocol is clear text. This protocol that we're proposing is completely pseudo-random. What does that mean? That means that if you take the entire byte stream on the wire between two nodes, the attacker cannot differentiate that byte stream from completely randomly generated bytes with a non-negligible probability. Okay, so that's tech speak, but essentially it looks like random bytes. There are no patterns in it that can be used to do what we can do today, as we described with the clear text protocol. This is actually a very interesting property and still pretty rare amongst protocols, even that are trying to be private. But there are, like OBFS4 for Tor is one transport, which I think tries to do this. CTLS is another proposal for TLS, for pseudorandom TLS.
Okay.
But one of the interesting things here is that you can always encrypt, and encrypted metadata is always going to be pseudo-random. But then you need things like packet lengths, like how big is the packet? That has to be in clear text, or the key exchange that happens ahead of time before you establish a encrypted session is detectable, because not all combinations of bits are valid keys on a curve. So our protocol uses Alligator Swift to make the key pseudo-random, and then we have a 2-layer encryption scheme to encrypt the packet headers as well. We've added observability of active attacks. What that means is there's a session ID that is derived from the key exchange. So if you and I are running an encrypted connection, if you do get peer info on your node and I do get peer info on my node, it will give us both a V2 session ID. And if we can compare that, for example, on a call, because we know each other, or somehow, the attacker can still be doing something where they run a node. They're like, oh, I'm going to intercept this connection. They have a Bitcoin Core connection with me, and then they have a Bitcoin Core connection with you. And they're just relaying everything. But if they do that, our session IDs will not match. And so they have to risk getting caught when they're doing active attacks. Okay, we already talked about the pseudo-random byte stream. We've also made the entire byte stream shapeable. So let's explain traffic analysis a little bit. So let's say you're not able to differentiate now the bytes on the wires themselves, right? Because they're pseudo-random. and you are incurring this cost. If you do an active attack, you have to run a node, and then also you incur the cost of getting caught. Maybe you can still do things like, I'm going to just run a Bitcoin node, and then I know exactly when a block is published. I know block publication is pretty fast now. Propagation is pretty fast now. So within 5 seconds of that, if you receive roughly exactly that many bytes, then you're probably a Bitcoin node. So, and this is happening because there are certain events in the propagation of the traffic that everyone needs to know about. So there are these patterns. So traffic analysis is what that is. But we've built shaping into the entire byte stream, so right from the handshake. So what that means is there are provisions in the protocol to stuff in dummy data to change the shape of the stream. So I could make it look like I'm sending you a block, because it would be roughly a block amount of data. And but inside the encrypted packet, I would have told you to just discard it. It's not actually a block. So I'm fooling somebody watching the amount of traffic going between our nodes, to thinking that that was a block. And so if you just do that every now and then, that pattern of traffic is not the same as the pattern for a Bitcoin node that's not shaping. So that's a circumvention provision that's built in. The way the BIP is structured is we are only requiring that nodes that are supporting the BIP, they ignore decoy traffic when they receive it, but we are not injecting any decoy traffic right now. That can be done at a later version, at any time. It does not require protocol upgrade.
Okay.
The other things we've done are, I'll go over these fast because I know I kind of went pretty deep on some of these.
No, you're good.
So forward secrecy. So let's say somebody is able to compromise our encryption session keys. What forward secrecy does is every 256 messages, the keys are actually hashed and ratcheted forward in a way that, so if an attacker compromises our key, they can never go back and look at our old data, because hashing is a trapdoor function, right? So we've built that in here, which is a pretty simple and cheap mechanism to get a very nice property. We have upgradability here, which is, so one of the interesting things is if you make the entire byte stream pseudo-random, you are eliminating the possibility of upgrading in some other way, right? Because if this is the V2 protocol, how is the V3 protocol going to announce that this is the V3 protocol? Because any V3 pattern would be a valid pseudo-random pattern. You couldn't upgrade it without having upgradability built into the V2 protocol. So we have versioning built in, and this is also going to be useful if we ever want to do things like optional authentication, post-quantum computing handshake upgrades, etc. The encryption is opportunistic. So we don't want to risk network partitions, right? We don't want situations like only V2 clients can talk to V2 clients, and only unencrypted clients, V1 clients, can talk to V1 clients. So the way the protocol is structured is, if your node signals to me that you're V2 supportive, and we can talk about the signaling mechanism in the demo, then I will try to make a V2 connection with you. But if it doesn't work, then I will try again to make a V1 connection with you.
Okay.
So it downgrades automatically.
Okay. So, and yeah, that was kind of going to be related to my next question. So, like, is this something that requires a hard fork, a soft fork? Is this going to be switched on by default for users? Can you touch a little bit on that before we jump into the demo?
Yeah. So hard fork, soft fork, those things are consensus layer things. We are not touching consensus here. This protocol is changing how things, so for example, how a transaction is propagated from node to node to node, how a block is propagated, or basically how all traffic is propagated from node to node to node. It is not changing anything about what's in that traffic. So think about this as more like you were using HTTP, now you're going to use HTTPS. It doesn't change the website you're loading. It just gives you better security guarantees and properties on that connection. So yeah, so nothing like that. And then on the network end, we've made it opportunistic, like I described. So to minimize the probability of just partitions. happening because of the transport layer. So a network partition is not related to a chain fork, but it can become dangerous for chain forks.
Okay, fantastic. And yeah, so you have oh, my mouse is not working all of a sudden, but so we have the bit that's available here on GitHub, and you also have the pull request open as well. What is the current state of the pull request?
Yeah, so can you go to your BIP324.com tab, your first tab?
Yep.
Click on code review on the left.
Yep.
Yeah, so if you go to this page, these are all the PRs that need to be merged.
This diagram is very sick, by the way. I love it.
It's funny because you kind of have to break things into small PRs to get traction on reviews and make it convenient for reviewers. But then also, I have to go back to this often to be like, I made a change here. What are all the PRs where I need to propagate the change to?
Yeah.
So and underneath it, you're gonna see kind of, it describes when each PR was created, what it does, if it supersedes some old PR, and below it there are PRs that were merged before, also abandoned PR. So all the information, this is the starting point for anybody that wants to review code. You can come here and you can do like a full archaeological survey of the history of this project, which I did when I started working on it. So just documented it here. Okay,
Fantastic.
so the PR we're going to run today, if you go up all the way to the diagram, 24545. So that PR has all the code where the 3 arrows come in. Yeah, this PR has all the code you need to run a BIP324 supportive code on mainnet. And because this is just a transport protocol, you can actually run it on mainnet. I mean, I wouldn't advise anyone to run this for their main node where they keep their funds, like the wallet is connected to, but if you have other nodes, you can safely run this and it should be fine. A lot of people are running it. The instructions are right there. Some of the addresses that I know people have told me I can put there are also there. So the first post on that PR has all the information you need, but we're also going to go through it today.
Okay, fantastic. Wow, I can't believe my mouse just died midstream, but I'll use my laptop touchpad for now. We should be all right. If it's a headache, I've got some batteries in my drawer. I'll dig up. But okay, so can you just very briefly, we've got about maybe 45-50 minutes, just explain like what we're actually going to do in this demo then?
Yeah. So what I would like to do is have you run a node, and then we're going to connect it to a V1 node, so a clear text protocol node. We'll just get some random node off of bit nodes, so we know there are no games being played, right? And so we will connect to that, and we will run Wireshark and watch the traffic that is sent. And through this, we will learn exactly how that deep packet inspection censorship can work. And then we will find a V2 node from some awesome people that are running it. And we will look at that in Wireshark, and we'll see that the traffic is completely encrypted.
Okay.
Yeah.
Cool. All right, that sounds fantastic. All right, let me change over to kind of my window that's got terminal and stuff on it. Bear with me 1 second, people.
Okay.
Let's present again. And if anyone's got any questions in the chat, feel free to ask them as we go along. You don't have to like leave them to the end or anything like that. Let's see if I share this screen. Okay, so yeah, I mean, I did a very minimal preparation, and I've got some stuff set up already from like previous streams and stuff. I basically cloned the Bitcoin core repo, and I'm on a Mac, so I basically just built it from source and compiled it and all of that good stuff. There are some instructions if you head to, at least for Mac anyway, if you head to the Bitcoin GitHub and the doc and build OSX instructions. I think there should be instructions for Linux and the like and other operating systems as well. So because I didn't want to bore you with compiling core, and it can take forever, but if people are interested in like the setup for contributing to Core. I did a live stream with Gloria Zhao, maybe like nine or so months ago, something like that. And we ran through this, so feel free to watch that back. In any event, I've got an instance of Core running, and I've checked out your PR as well. And I've got Bitcoin running in the background. Just to make sure that that's the case, I'll run a little alias I've got for the Bitcoin CLI, and we can kind of see that I'm synced up with the latest block on the network. So I think I'm ready to go. So I'm kind of, where do we kind of go from here?
Okay, so where is your config file for this node? How are you running?
So my config is, let's see, directory, and I can do code Bitcoin. Okay, oh yeah, my thing's not working. So my config file currently looks like this.
Okay. So right now, we're not going to change this at all, but later on, we will come back to it. So there is a new command line flag in the PR that you're running. It's called V2 transport. So we refer to the BIP324 transport protocol as the V2 version 2 transport protocol.
And this goes in your config file? This would be like an addition to your config file, or you run it when you start the daemon kind of thing?
That's the same thing. So
okay,
it's
the same. Yeah, okay.
Picks up command line R's essentially.
Okay.
So the V2 transport flag is set to default false right now. So your node right now, even though you're running my branch, is not going to, it's not going to signal support for V2, and it's not going to make V2 connections.
Okay.
So let's just do that to show how things work today, and then we can go from there. So let's do. So can you open up Wireshark as well and just leave that open?
Yeah, just so people, for people who might not know what that is, what is Wireshark? I'll go to the website very quickly. And
yeah, it's a network inspection tool. So your operating system basically knows all the bytes that are getting sent and received, and Wireshark is a way to kind of tap into that and visually see the packets.
Okay, cool. So yeah, I guess I need to just open Wireshark. I've got that already.
Leave that open there. And so what we're going to do here is your node is running on 8333 because I don't think you've changed the port based on your config I saw. So let's type into that box. You see where it says enter capture filter. You can say TCP space port space 8333. Yeah, okay. Perfect. And so, I mean, honestly, we don't even need to connect to a V2 node, right? Because your node is already connected, or V1 node, because your node is connected to other V1 nodes right now.
Okay.
So let's click on one of these packets. So yeah, just click on something. Click.
So
you can actually stop the capture now, so it stops moving. Or maybe you scroll up. If you scroll up, it'll stop too. Okay, that's fine.
So one of these ones.
Yeah. So look at that. So it made a get data call. Right? A get data is a Bitcoin P2P message.
Okay.
And look, Wireshark can even tell you that it's the Bitcoin protocol because Wireshark has built a plugin which comes by default with it. And it's actually able to, it's doing the deep packet inspection we were talking about. So you can see that get data call. Click on that TX. It's about 2 lines below that. There's another packet that says TX. Yeah. That's a transaction, right? It's if you look at the source and the destination, it's coming to you. So somebody sent you a transaction. And if you click on that drop down next to where it says Bitcoin protocol,
down here.
Yep. See, like it even knows that it's a transaction message. So click on that drop down again.
Yep.
Wireshark is literally telling you the N version on the transaction. It's telling you how many inputs are in the transaction. It's telling you how many outputs are in the transaction.
Wow. So this is the first time I've actually done this. This is kind of cool. It even tells you like the script output. Or the hex for the script output. Interesting.
Yeah. So Michael is asking if
value
I've
as in,
used this code in Bitcoin Core that does similar stuff. I have not. I have not used it.
have you used the like Wireshark coding core at all? I'm not sure if it still works. Okay. This is interesting. Okay.
The
Okay.
interesting thing about using Wireshark, though, Michael, is that it is an intermediary, right? Of course, the Bitcoin Core code knows the Bitcoin Core stuff, but this is an intermediary, and we're trying to emulate an intermediary in terms of an ISP or a passive observer.
Okay.
Okay, so cool. So we don't need to do the V1 connection at all, right? So what we can do is let's do a V2 connection, and we'll watch for that. So I think a website you can go to is b.anyone.eu.org.
Okay, you sent me that earlier, I think.
Yeah, that's the one. Okay, yeah. So this is some kind soul on Twitter who is interested in the project. He's running this node, and it's BIP324 supportive. So you can go all the way down, and you see that he has IPv4, IPv6, he has Tor, he has I2P. We're just going to do IPv4 for now. So pick that first address and port, the 78.98.22.31.
Yep.
And now go to your Bitcoin Core config.
Open, yeah. Okay.
Let's add a few things here. So let's add a new line that says V2 transport equal to 1.
Or just one word, yeah.
Yeah, just one word.
Transport equal 1.
And then let's add a new line that says, let me see. Let's do add node equal to addnode equal to, and then just paste what you got from that website. Yep, perfect. So what this is doing is now it's telling your node that it should signal support for V2 transport, and that if somebody else is signaling support for V2 transport, you should add it.
Okay.
Actually, sorry, one second. I'm wrong about this.
Is the port in a separate parameter?
Don't do add node, and I'm about to explain why. So now I think it's a good time to talk about how would a node know whether another node is a V1 node or a V2 node. So your node knows BIP324 now that you've added V2 transport equal to 1 once you restart it, obviously. But this other IP address, we don't know whether it's running V2 enabled code or not.
Of course. Okay. Yeah.
So we're going to talk about the signaling mechanism that is used. So for
unless you obviously out of bound, you know that this person's, like we just did, we know in this instance this person's running V2, right?
Yeah.
But
so
you're just saying if you want to,
I'm doing all of this to motivate how we will do add node. But
okay,
you're right.
cool.
You're right.
Yeah.
Obviously.
Yeah. Okay.
So your node wakes up. It asks the DNS seeds typically for who are some other peers to talk to. And then every peer, every so often, will broadcast other potential peers to you. You can even query a peer for other potential peers. So basically, what you're doing is you're saying, I want more peers, and I'm just going to keep asking people, and they're going to keep telling me. This is called adder relay or adder gossip.
Okay.
Adder refers to peer addresses in Bitcoin Core, and address refers to Bitcoin addresses, right? So we call them adders for that reason. Okay. So when someone tells you about a peer, they also send you services they support, whether they support SegWit, for example. And so we've added a sorry?
As in like services like Tor or?
No, services like SegWit. Like, does that node support a segregated witness across the board? Okay. Or, there's a bunch of these flags, and P2P v2 is a new flag that is being added with this specification. So let's say Michael's node tells me about the existence of your node. So when it tells me, hey, by the way, Connor's running a node, it will also tell me, and that node is supportive of P2P v2.
Got you.
So if I know that, then when I initiate my connection to you as an outbound node, I will try a v2 connection first. And then if it so turns out that Michael's node was being deceptive, I will also downgrade to V1 and try a V1 connection. So that's how we make sure that Michael cannot censor your node from getting a connection from my node. But so that's the signaling mechanism. Now we are adding a node manually, and on the command line, we need to tell your node that this other node is a V2 node. We need to emulate the signaling mechanism, right?
Okay.
So what we're gonna do is I'm gonna send you a command here, just really quick.
Okay.
Just give me 1 second. All right, so I've sent you a command, but first I want to make sure the Bitcoin. So you can remove that add node line.
Okay, remove.
Yeah, remove that node line and restart. Save this config and restart your node.
Let's see here. So I can just stop it altogether. Stop. I'm in the wrong place. I'm now. Go into projects, CD, Bitcoin. And okay. Okay, cool. So, all right, I've just stopped it.
Yeah. So now we want to just start it. So that way your node will be.
Yeah.
Yeah.
Cool.
Cool. So can you do get peer info? BC get peer info. I just want to make sure there are some peers.
Yeah.
Perfect. And let's go to Wireshark and make sure we're still capturing traffic.
Yeah. I think I have to load this up again. Continue about saving.
Perfect. You're getting traffic. So this is your V. This is still your. Now you're running a node that's V2 enabled, but obviously you don't have any.
Outbound connections to
V2 peers, right?
Yeah.
So let's go back to your command line and run the command I just sent you. Can you paste that, but don't run it? I want to explain the command.
Okay, 1 second.
But you also notice now you did get peer info. I just want to point out it has. So do get peer info one more time.
Whoops.
Control U, by the way, is a very useful command that'll just wipe out whatever you've typed.
Okay.
Short.
What do I want to do? Get peer info again.
Yeah, get peer info. Yeah, so you see how now it says at the bottom of every connection, it says transport protocol type V1.
Where am I looking? Oh, yeah. Okay.
It's the very bottom. Yeah. This means that's a V1 connection, right? So we're now going to make a V2 connection. So we'll look for V2 in that case. Okay, so now type BC add node, that command I sent you.
This one. Oops. How have I just copied that? Let me copy this again. Okay.
Great. And let's change. Let's change that IP port thing to the thing from that website where the guy's running a V2 node.
Got this one here.
Yep.
In quote to keep the quotations, or can remove them. Yeah,
keep them, please. Okay. So I'm going to explain this now. So what we're doing now is we're telling your node, hey, can you try to add this other node as a peer? One try is a type of connection, so it's just going to try once. And actually, that's not what it is. But I don't want to. It's a type of connection in Bitcoin Core. It's a manual connection we're making. And then the last parameter that says true, that is the signaling mechanism over the command line. So that is what tells your node, hey, that other node supports V2, so try to make a V2 connection first. Okay. Because we did not learn about this peer from Adder Gossip. We learned it just out of band.
Oh, so that was actually going to be my next question. So how would you learn about peers that support V2 automatically without manually doing this? Is this the adder gossip that you just mentioned?
So it's adder
Okay,
gossip. So every
got
node
you.
advertises itself to its peers, I think every
Mm-hmm.
24 hours. I might get the details of this wrong, but
Mm-hmm.
also every node also broadcasts a bunch of potential peers to every other node every so often. And this is the mechanism called adder gossip that tries to get the knowledge of potential peers out into the world. Yeah.
Okay, got you.
But we
Okay,
can circle back to that at the end if there's time and you want.
okay. So do I just press enter now? Ready to
Let's
go?
do it.
Or
Let's see if
yeah.
it works. Yeah. Now, can you do get peer info again?
Yeah.
There you go. You have a V2 type peer now,
Oh, cool. Okay.
and you have a session ID. This is the session ID that you could compare if you wanted to compare. Which he's actually also built a way to compare it, so we can go there too, depending on how much time you have. But
So
for
is the
now,
session ID the same on the peers end as well?
yes,
Exactly the
exactly. So
same?
if
Yeah.
he does
Okay.
get peer info, he's going to see exactly the same thing. So you could get on a call
Okay.
with him, and
Yeah.
you could verify it.
Okay.
And if you verify that, that means that there is no active attacker in
Got you.
between.
Okay.
If you have
Okay. Yeah, of course. Yeah.
man in the
Got you.
middle attack.
Mm-hmm.
Okay, so now let's go back to why. So can you go up actually?
Yeah. Straight to the
And
all the way
just
to the top.
just
Okay.
just that peer. Or I just want that. Make sure you have that IP port in your clipboard.
Let's
Just a little tiny
see.
bit. Stop. Copy the adder from there. Yeah.
Including the port, yeah.
Yeah.
Okay.
And now let's go to Wireshark. So this whole time while you were adding the peer, Wireshark has been capturing all the data. So
Yep.
you see that little box up top where it says apply a display filter. So this is
Yep.
all your peers. It's a lot of traffic to look at.
Yeah.
We're going to filter it by just this peer. So put inside parentheses, can you say inside parentheses, open round bracket? Yeah. And then ip.source, ip.src
Yep.
equal to, and that IP address you just copied.
Yep.
And remove the port, please. Sorry.
Okay.
Or. So pipe.
Yep.
ip.dst.
DST. Yep.
Equal to. At the same IP.
Yep.
Yeah, remove the port again. Great. And close the round bracket. Enter. Oh, I think it's already okay. Cool. So what all Wireshark is doing now, it's only showing you the traffic for that peer.
Okay.
So we can just kind of and notice how it does not know anything. You remember how before if it would show you Bitcoin some places.
Yeah. It'd show you like under this protocol column.
Right.
You'd
It
have
was
like
doing
Bitcoin.
protocol inference
Exactly.
there.
Yeah.
And
exactly.
now it's not able to do it. And so
Wow, okay.
this is where we have to mention that, and that's maybe I could just change the V2 protocol to be a different clear text protocol, and Wireshark would not be able to do it, right? They could just not have the plugin yet. So that's a caveat. People should go verify the construction of the protocol, or take these bytes on the wire and build the histogram of all the bytes, and you should get a uniform histogram. There should be no pattern in these bytes. But you can also inspect these packets. Like if you remove that filter, you'll see that sometimes you see the word Bitcoin, get data, TX. You see these words in the contents of the packet. But yeah, so if you
like
go,
now,
if you click on click on an INV packet or something, or a get data packet.
So
click
data. So like one of these.
There you go. Yeah. So if you look into these bytes over here, on the right, and scroll a little bit, scroll in that box. Okay, so go to the previous packet. Those are just you see get data over there. That's literally the bytes on the wire are the ASCII bytes for get data. But when you have IP source and IP destination set to this V2 peer, you don't get any of this in the contents. So if you put that filter back on, now you can go through these bytes and you won't see any discernible pattern. So it's just a visual check, right? It's not a statistical check. This is not,
Yeah.
we're not doing the right scientific methods here.
Yeah.
We should. And I encourage everyone to. But yeah, you can
Mhm.
go through these packets and there are no discernible patterns in those bytes. So this is
This is
the
pretty cool, man.
demo.
It's very cool. So yeah, like there's no way for us to distinguish like any block propagation stuff, any just peer-to-peer messages. It's all just like it all just looks the same, right? And so
For a
by
passive
default,
observer that's just looking at the bytes, there's still
yeah,
traffic analysis like we talked about,
yeah.
but there are methods built in to mitigate those attacks into the protocol. And one of the interesting things about the game theory of Bitcoin is if there's a mechanism to defeat traffic analysis, there's no point in doing the traffic analysis, because if you start doing it at scale, then we will deploy the shaping at scale. So it's almost as though, it's almost as though having like if a country has defenses, you are less likely to attack it, because what's the point of attacking it? Yeah.
Waste the resources, basically.
Right.
Awesome. Okay, cool. It's a very, very, very cool stuff. Any other directions you want to take us? If there's any questions, sorry to cut you off. If there's any questions in the chat, feel free to throw them our way as well. Yeah. So any other directions?
Let's verify the V2 session ID. How do you feel about that? Do you want to do it?
Yeah, sure. Yeah, let's go for it. Yeah, we got about about 10 minutes, and then we'll leave a bit of time for if anyone has any questions. So yeah, why not?
Sounds good. I'm gonna send you a link, a GitHub link.
Okay.
So go to that GitHub comment, and then I've not done this before, so we're just gonna do it live.
That's what it's all about. Freestyling. I like it. Let's see here. Okay.
So you read that comment and read update 2, right? He says peers can come and verify their session IDs, the addresses without the square brackets, and what follows after the closing square bracket are MD5 hashed. Okay, so sorry. So the addresses without the square brackets and what follows them.
And only the first 16 bytes of the hash are shown there.
So yeah, click that link where he says verify the session IDs.
Yeah.
And
let's see, let me zoom in a bit.
Yeah, so you basically see what he's doing on his node is this page is being rendered by him running this command, this last command, Bitcoin CLI get peer info. So he has 6 V2 nodes connected to him because a bunch of us are testing.
Okay.
But then he's saying get peer info, and he filters by V2 nodes, and then he gets the adder, and then he does a bunch of stuff, and it prints this. Can you run that exact command? Yeah, just copy paste that thing and replace it with BC for you.
Yeah.
So he doesn't want to expose his peers' IP addresses, so he's hashing the IP addresses. Otherwise, you would be able to see who the 6 V2 peers are. So that's just something he's doing for privacy for people.
So can we run through this one more time again? So he's calling get peer info. He's doing this JQ to pipe.
Do you have JQ installed, by the way?
I should do, yeah.
Okay.
We'll find out in a second.
We can try.
So he's filtering on, he's filtering on the transport protocol type V2, and then he's getting the session ID, and
he's taking your adder and the session ID, and then he's piping that into an
MD5. Right, got you. Okay, that makes sense. So let's see. I should have JQ, but let's find out.
Yeah, okay. So this is what you got from your get peer info. So you hashed you hashed the session ID. See if this matches something on that web page, the E76 thing. Does this match something he has on his web page?
Let's see.
No, that output.
Here. Okay.
I don't see it actually. I don't see an E76. So most likely, what's happening is his what he sees for adder is
Mm-hmm.
your adder, and what you see for adder is his adder. So go back to the command line
Mm-hmm.
and do get peer info one more time,
It's a normal one.
and go up slowly. Stop. So can you run that again? Oh, you don't have MD5 sum installed, someone says.
You don't have MD5. Can I do that via Brew? Is that something I can do in Brew or?
Can you run that command again? Did we get an error that I just
Yeah, I think
glossed over?
we did actually. Yeah.
Oh, I
So
just glossed over. Oh, okay. Yeah.
MD5 sum is that? Can you do that in Brew or?
Try it.
Let me try it. Brew.
If it's a development machine, then yeah.
MD5 sum. Let's give this a go. Okay, looks like it's got Brew has it.
Oh, weird that I didn't even read that error. Gotta slow down.
Yeah, it's not super highlighted, to be fair. I kind of glossed over it as well. Okay. That's why we have the chat to help guide me through some stuff as well. Any questions in the chat? How you guys finding this? Has it been useful? Is this exciting to you? Are you looking to run? If you're running a node already, will you be quote unquote upgrading to this version 2 of the protocol? Let us know. We have a question from Michael. Let's see here. So, might you want to only encrypt a subset of the peer-to-peer messages if it is public data to avoid the decryption overhead? I'm guessing not.
Yeah. Well, so first of all, even with our conservative benchmarks, the encrypted protocol is 97%, as so 3% slower than the previous old unencrypted version. Stream ciphers are really, really fast. We're using CHA-20 poly 1305. And the old protocol, the checksum is a double SHA-256, which is very slow. So it's actually not slower. In terms of bandwidth, it's actually cheaper. Every message is 3 bytes smaller now because we've built in 1 byte message IDs. Also, it's just like if we do something like that, we're always going to be having conversations about, is this message type worth encrypting? Is this message type not worth encrypting? The bulk of the traffic on the wire is transactions, right? And blocks. So, and the bunch of the privacy implications are in those parts. So I don't really know that complicating the design for little to almost no gain is worth it. I think having a completely pseudo-random byte stream also gives us very, very nice properties. For example, if you don't encrypt some messages, then you're still leaving yourself open to the censorship attack that we talked about. Like there's still deep packet inspection possible, and you just completely lose that property.
Okay. It didn't find the package in Brew, but it recommended a different one, MD5 SHA-1 sum. So I've tried to pop that into logic here. So instead of what was it before, MD5 sum, I've gone
I
with
think
MD.
that's going to make a different
Is that going to
hash, so
completely?
you
Is that
might
going to
not
completely mess it
match.
up?
I don't know. I don't know how MD5 works, so I don't really know. But
Okay, command not found MD5 SHA-1. Okay, still not finding it.
let me see. MD5 sum.
Anyone know where I can get this library from for Mac? Optimistic. We got another question. Optimistic date for merge. While I'll try and
Well,
Google
I
this.
think if everybody here runs nodes and makes themselves heard in various channels, whether IRC or Twitter, and we get some interest going, the code is all there, right? And I've done. I mean, I'm not like like a super coder, but like I've done my best to make sure the code is pretty good, and a lot of the testing is done. And so I in Bitcoin Core, I'm never going to pick a date. Like it's going to depend on the community, but I can promise you that it's my highest priority to get it merged. And every time something gets blocked on me, I will move it forward. The working group, we didn't even talk about like Peter and Tim, who are my co-authors, and I'm sure they will be doing everything they can to move it forward as well. So it's I like to think of it as it's in the community phase now. We have to come together and make sure that it gets merged.
Sounds good. I'm just while you're talking, I've just been playing around with different MD5 packages and it's not quite working. But okay, but I get the gist of it anyway. Like if once I know which library to install, you can basically run it through MD5 and compare it against.
Yeah, and that's just
what
for
other-
him, right? But
Yeah,
really, like
exactly.
it's kind of like think of the session ID as that thing Signal has, where it
Yeah,
shows you a bunch of things and you can compare it with the other person. And if
yeah.
they match, then you're not being man in the middle attack. That's what the session ID is supposed to be. In the
Okay.
future, if people build upgrades to BIP324, which it allows for, let's say that have authentication, and you and I can exchange pub keys off band, then we can take this session ID and we can commit to it using our public keys and build binding, right? Like that would then be a binding. Then the code could alert you if there was a man in the middle attack, rather than you doing a manual um, uh, a manual check. So yeah, but anyway, think of it like the thing in Signal, where if you compare it, then you're safe.
Okay. I'm gonna
The
try
safety
this.
number, they call it, I think.
A couple other questions. I think the BIP co-authors consider the BIP finalized from an
No,
American.
I don't think so. I think we're still looking for feedback. The most active conversation right now has been around the one type message type IDs. So in the V1 version, 12 bytes in the message header are reserved for the ASCII type of the message, which we were seeing in Wireshark, right? Like get data. In the new proposed protocol, we use 1 byte, and that number is assigned to a message type ID. So that gives us some of the bandwidth improvements we end up getting, despite having a MAC tag, a 16-byte MAC tag. So there's some discussion around it. Should every message type have a one type ID, since there's only 255 of them, or should we reserve? One cool idea that Merge had, I think, that he talked about, was you could keep 0xFF, so the number 255 type ID, as reserved to signal that it's actually a 2-byte ID. So then you can even go past 255 types. One thing's been discussed is maybe we should not be allocating one byte type IDs to messages that are infrequent. So that's a conversation that's ongoing. I don't think we're finalized, but I can say safely that we feel pretty good about the design. There are small things that might change still.
Okay. All right, Drew. In just in the interest of time, I've kind of stopped sharing my screen, and we can kind of start to close down a little bit. But thanks for that. That was super interesting. I've personally never done a lot of like even I don't think I've ever like ran Wireshark or done any like kind of network observation stuff. So it's quite interesting for me personally. So I appreciate that. Thanks for that. Very exciting stuff. Is there any more questions from people watching? Dhruv, how do you want to? What kind of stuff can people do to test this, get involved in this, help spread awareness about it? What kind of contributions would you like for this proposal going forward? Reviews, that type of stuff.
Yeah, I mean, like whatever you're interested in and whatever you're skilled in, right? So if you are, if you're interested or skilled in like review, and especially for people that are, when I started this, I had only done like the Dan Bonet cryptography course, and I knew what these things were, but I didn't know the inner workings of Cha-Cha 20, for example. But in doing this, I actually found optimization bug in Daniel J. Bernstein's Cha-Cha 20 code that we had in core. So it is this like a great way to get closer to cryptography if you want.
Okay.
And if that's something you want to do, I'm happy to jump on calls and help you along that journey in whatever capacity I can. I'm by no means an expert, but it's not this thing that is like out of reach. Like everyone can learn it is what I've learned.
Mm-hmm.
So whether you're interested or skilled in it, like there are
Mm-hmm.
different PRs that are closer to the cryptography. There are some PRs that are closer to the networking code. There are
Mm-hmm.
some PRs that are closer to kind of bringing it all that together and kind of, the protocol itself.
Mm-hmm.
So go to the PRs that interest you. And at a minimum, I think everyone on this call, if you survive till this point, you can run the nodes and you can talk about it on Twitter or IRC, and you can encourage other people to pair with you. If you give me the addresses that where you're running V2 nodes over any
Mm-hmm.
channel,
Mm-hmm.
I'm happy to add them to the PR description. Let's keep that list growing. Let's
Mm-hmm.
have more and more nodes that new people can peer with, and the more this is tested, the better, right? We want to see that nothing's crashing over a long period of time. And that's something we can keep doing in the background while we code review. If people have been running the code on mainnet for 4 months, 5 months, 6 months, the nodes are not crashing, it gives us a lot of confidence. It's just, even if it's just black box confidence. So, yeah.
What type of what does this look like with regards to kind of review and stuff that of the actual code? Is it got sufficient eyes on it in that regard? Is like, are the right people kind of reviewing it and stuff, quote unquote right people? Is
I know the right people. I know many of the quote unquote right people are interested. It has seen some review, but I wouldn't say that we have crossed the activation energy threshold on these
Okay.
PRs by any means. But it'll get there. I think it's like more conversations like these, more people interested, more people running it. Ben implementing it for Bitcoin S, for example, something he's talking about. I think, Ben, I think you could hack it together in a few days. I don't know if like a weekend will specifically be enough, but I'm also happy to help make that faster. And I think that's another thing that's useful. So in integration tests, we re-implemented the whole thing in Python to make the mock nodes connect to the real nodes, and that was very helpful because in cryptography, if the two implementations are different, they're not going to be able to talk to each other. And yeah, if Ben implements it, that gives us more and more and more confidence that there aren't any kind of dependency related differences in implementation that could break this across implementation. So yeah, sorry, to go back to your thing about review, I think we need more review, but we also have not enough, we also have several of the right people interested.
Okay, fantastic. Okay, sounds good. And is there any kind of last messages before we kind of wrap up and sign out kind of?
If you're feeling sad because of everything that's happened, like I highly recommend, like I don't know if everyone's wired this way, just making something helps me. Like make anything you want to make. Like if you were personally hurt by what has happened, or you just generally feel sad that like we end up in an industry where people can do something like this, like yeah, just, and if you want someone to talk to, like I will talk to you, like let's hang out, like I don't know, just if you're sad, I'm sorry that what's happened has happened, but you will get through it.
Yeah, likewise. I'm definitely here for conversations and stuff. And yeah, I mean, yeah, being in the space where you're building constantly kind of gives you a lane to be optimistic, and you can see the potential for something like Bitcoin when you are kind of at the forefront of helping to build the technology, helping to uncover new use cases, helping to increase its censorship resistance via privacy and other mechanisms. So yeah, just keep up. For anyone watching, I thank you so much for watching. Drew, thank you for your time. Keep up the good fight, and yeah, we'll see you guys soon.
Thank you for having me, and see you soon.
Peace.